Alright guys, so today what we're going to be talking about are congruent figures. So previously when you were in middle school, most of your teachers taught you that congruent figures have the same shape and the same size, and that similar figures have the same shape but different size. And while these are good general definitions, what we're going to do this year is we are going to clarify and be more specific about what it means to be congruent and similar. So this video is going to focus on congruency. So here is the exact definition for congruent figures. To be congruent, figures must have all angles congruent and all sides congruent. And remember, the word congruent means to be the same. The symbol for congruent is this. Have an equal sign with a squiggle above it. That is the sign for congruence. If you see that, as in saying A is congruent to B, this means that A is the same as B. So last year you learned all about translations, reflections, and rotations. And what we're talking about this year with them is that any time that you have a translation, a reflection, or a rotation, you do not change the figure. So if you can prove that two figures have been translated, rotated, or reflected, you can prove that they are congruent. So just a quick reminder, a translation is a slide. So that would be where you might have a triangle slid over. And if it's been translated, all of the sides are the same. So if this is 1, 1, and 1, this one is 1, 1, and 1. And all of the angles would have to be the same. They would all be, what would all the angles be for them to be the same? Obviously, this is an equilateral triangle because all the sides are the same. That means all the angles are the same. 60 degrees for each one. 60, 60, 60, 60, 60, 60. Okay, they all add up to be 180 degrees. For a reflection, same thing. If something is being reflected over a line, let's say the letter N, and this is our line of reflection, when you flip it over, it's going to look like that. All right? Now, yes, it is facing differently, but if I had not freehanded this, they would be exactly the same. Okay, and then a rotation would be if you had a triangle and it was rotated 90 degrees to the right, or 90 degrees clockwise. Again, nothing has changed. Those triangles are still exactly the same. So, these are what we call isometries. And isometry means that it's a movement that does not change the triangle. Now, the big thing that you have to know about this is how to write congruent statements. So here we're going to have two triangles. I'm going to label this one A, B, and C. And we have another triangle that is congruent, and we're going to label it D, E, F. Okay? So we have to write a statement that tells us that these two are congruent. So first, you name one of the triangles, and we'll call the one on the right triangle A, B, C. And it is congruent to triangle. Now, the way you find this is you have to find the corresponding angles and the corresponding sides. AC line corresponds to DE. Angle A corresponds to angle D. So where there's an A down here, I put a D in the other one. And then with C is corresponding to E. So that means that E is going to go here. And then F is corresponding to B. So it goes in the same place that B does, right there.